Hey everyone, I want to show you how we analyze the data of the measurement for the 2-minute walk/push test. Now with this test, we're basically measuring aerobic endurance, and for individuals that are in a wheelchair, they'll be pushing for 2 minutes, and for those that are ambulatory, they'll be walking for 2 minutes. And at the pre-test and post-test, we'll be measuring how far they go in meters. So let me share my screen here. Okay, so for the purpose of our program, we have 4 participants in the group, and at pre-test, participant 1 went 10 meters, and then at post-test 13. Participant 2 went 9 at pre, 11 at post. Participant 3, 14 at pre, 15 at post, and participant 4, 7 at pre, and 9 at post. So very similarly to the box and blocks test, with that statistical analysis, we decided to run some descriptive statistics, a t-test, and a correlation as we've decided on pre and post tests for one particular program. Now this will give us the information we need to determine if the information was statistically significant. So first we're going to start with the t-test. So we'll go to data analysis. We'll go down to a t-test. You want the paired 2 sample for means. Okay. We'll take out anything that's already in these blocks. So the variable 1 range, you want the pretest, you'll highlight that, including the label. And then variable 2, you'll highlight that, also include the label. And since we decided on including the labels, you'll have that checked out. You want the hypothesized mean difference at 0. Keep the alpha at 0.05. That'll show us if our p-level is below that, which would make it statistically significant. Then for your output range, that's just where you want this information to be shown at your screen. So I'll put that right here. And then let me spread this out a little so you can see the information. So, we have our mean, our hypothesized mean, observations and whatnot. We're mostly going to focus on the mean and the p-value. So the p-value here, you're going to pay attention to the 2-tau one. So this is 0.01, which is statistically significant. So now that we have that information, we want to find the standard deviation. So we have to run a descriptive statistic. So back to data analysis. Go to descriptive statistics. Okay. And then we don't want the range here. Take out information that was already in there. So we'll start with the pretest scores. We'll keep that at Collins. You want the label checked off again, and make sure these last 4 boxes are checked off. And for the output range, I'll just put that right here. Click OK. And then you have your descriptive statistics for the pre-test scores. And then you'll have your standard deviation right here. So then we'll do the same thing for the post-test scores. Back to data analysis, descriptive statistics, clear this out and this out. And then we will highlight the post scores. You want columns, keep the label, make sure these 4 are checked. Output range, I'll just put it right next to the pre-test scores. And then you'll have that information you need. You can see the standard deviation here as well. So now that we've seen our standard deviation, we have our p-value, we have our mean, we can write out our findings. So for this one, we would write out a paired sample t-test was conducted to compare the 2-minute walk push test, pre-test, and post-test scores. There was a significant difference in scores from pre-test, where the mean for the pre-test, as you can see, equals 10, and the standard deviation, which is right here, equals 2.94, and post-test, where the mean equals 12, and the standard deviation equals 2.58. And then the T-score with 6 degrees of freedom, which this is the amount of data under the pretest, which is 4, plus the amount of data under the post-test, which is 4, add together 8, and then subtract that by 2. So we have 6, and then the T-stat, so that's right here, that's negative 4.89, negative 4.89. And then our p-value, as you can see right here, is 0.01. If we want to round it up, we can put it at 0.02 or 0.016. Regardless, it does make it statistically significant as it is below 0.05. So now we want to find our correlation. And again, similar to the box and block test, we decided to see if the number of sessions attended affects the 2-minute walk/push test, and see if that's statistically significant. Sorry, I have trouble saying that word. We want to test the correlation. So you want to bring down the post-test scores next to the amount attended. So the most amount of sessions attended would be 24. So say participant 1, 23 sessions, 2, 23, participant 3, 24 sessions, and participant 4, 22 sessions. So once again, we will go back to data analysis, and now we want to go to correlation. So for this one, we want to highlight both columns and then make sure that columns is marked, labels are marked, and then output range, we'll put that right here. Okay. So you can see that the correlation here is positive, so it does mean there's a positive correlation, but it does not necessarily mean it is statistically significant. So we have to run a regression analysis to find if it is significant. So to do so, back to data analysis, and then down to regression. Okay, and for this, for the Y range, you actually want to go to the outcome first. So the post-test, and then the X range, the number of sessions attended. You want your labels checked off, the confidence level, that should be at 95%. And then you'll choose your output area, make sure it's blank first, and then we'll go over here. Okay, so you can see they give you a lot of data with this one. But the most important one for right now is we want to find the regression and if it's significant. So under the ANOVA, you have regression, the significance. Here is 0.051. So while that is close, unfortunately, it is not statistically significant. So to write out our findings regarding this portion, we will put there is not a significant relationship between the number of sessions attended and the 2-minute walk/push post-test score. Regression number 6, which again is the degrees of freedom, equals, which is this number right here, 0.9, we will round up, 95. That's the correlation number, and then the p-value, which again is right here. Sorry. P-value equals 0.051, so it's not significant. So overall, we found that the pre-test scores compared to the post-test scores for the 2-minute walk/push test was statistically significant. However, there was no significant relationship between the number of sessions attended and the 2-minute walk/push test scores.